Today's topic, Java SE8 Lambda Quick Start, is presented by Mike Williams. Mike is a course developer in the Server Technologies Curriculum Development Group at Oracle. At this time, I would like to turn it over to Mike.
Thank you. Here's some of the prerequisites we have. But basically, you've done a little bit of Java programming, probably, definitely a requirement for this to understand Java. This is a little different from our normal Java stuff. And it's new and interesting, but very cool. And today we'll be using Java JDK 8. We're actually using build 111. That actually changed since I made this slide. But that's all downloadable, and I'll show you that in a minute. And then we're also using NetBeans 7.4, which is nice because it supports Java 8. So it has all the Java 8 features supported in 7.4. That came out yesterday, actually. So you can download that, and I will show you that as well early on here in the presentation. So here's an overview of what we're going to talk about today. First, I'm going to do a little housekeeping. I'm going to talk about getting the tools and troubleshooting any issues you may have, basically how to set up NetBeans to run two different JVMs. And then we'll get into Lambda Expressions. That's the main focus of our talk. We're going to talk about kind of where it comes from and what it's for. And then we're going to talk about the syntax. And then after we do that, then we'll go into a bunch of examples. We'll start out with some basic examples that are pretty much, like a one-for-one sort of thing. And then we'll go into like some more detailed examples on some applications. We'll talk about the Robocall application. And we'll also talk about applying a function interface using lambdas. And then finally, we'll have a longer section, a little bit longer section there on using Lambda with collections, because there's a lot of changes to the collections API and take advantage of the new Lambda expressions. So let's move forward here. So first, a little housekeeping. I'm going to talk about where to get this stuff so that you can do the same things I'm doing after the talk. And then some issues you might face downloading some of the source code I put up here a few months ago. So let me share my desktop. There we go. That is, in fact, my desktop. That is always good. Okay. So first, you probably want to get Java 8, and you can find it listed here, which is basically jdk8.java.net, and then I'm on the download page. And you'll see the current build is listed right at the top of the page. Just scroll down a little bit. You have to accept the license agreement. I've already done that, so it disappeared. But you will also see, you've got all the various platforms. There's two columns here. If you want the JDK, make sure you get the right column. That's something I often mess up. I forget and get the JRE, and then I can't compile anything. So anyway, just be aware of that. And then we're also using NetBeans 7.4. That can be found at netbeans.org. You can see 7.4 is the current version. Like I said, that came out yesterday. And the main reason you want that is because it has support for Java 8. And that's what we need for this class. All right. Now, the other thing there's a couple other things I want to mention. If you want to set up more than one JDK on your system to use with NetBeans, you do that by going to, I've got NetBeans up here and I've got some projects up, but basically you just go to Tools and you'll see Java Platforms here. And you'll see here I've got two platforms. I've got JDK 1.7 and 1.8. And I added 1.8 simply by doing this. You see down here there's a button, Add Platform. I'm going to click that. And then I'm going to go up a little bit here. So you just go to your C drive, navigate to where the JDK is loaded, and then here's 1.8. That's basically the root directory of all the Java stuff. You'll get a Next button when it recognizes, hey, that's a JDK there. You click Next, and then you basically would, I've already got JDK 1.8 in there, so thus I get an error message. If you hadn't installed it before, you'd have the option to click Finish to install it. So basically, that's how you set up multiple JVMs on, or versions of Java in NetBeans. And then the other thing I wanted to point out is the projects I created were all done with custom, basically with Lambda-only builds of the JDK very early on in the development process. So if you download one of the projects, I'm going to go here, File, and I'm going to open a project, and I have one here called Broken. And so if you download any of the projects from the OBE website, when you open it up, you'll get an error message like this. And when you say resolve problem, it's going to basically, remember I was just showing you the Java platforms. It's going to say, oh, this platform's not on your system, and of course not, because it's a newer version, so it's certainly not named that. So you can't really resolve it here. Essentially what you do is you just close out of that, you go to the project, you right-click it, you choose the properties, then you click on libraries, and then the library for the project here, you can select which platform, Java platform you want to use. You just select 1.8, and then that should clear out any error messages you get. You might have to open and close the project after you've made that change, but that should solve the problem. So that's a little housekeeping I wanted to go over, and we'll jump back to this here in a minute. So I'm going to go back to the presentation here, and that was the demo we just did. Okay, so a little background on Lambda expressions, and then we'll go into some more examples. So, and once again, I'm probably going to save, based on the timing I did from my run-throughs yesterday, I'm going to save questions for the very end, just to make sure I get through all the materials. So we're going to talk about anonymous inner classes, functional interfaces, and then the Lambda syntax itself. So let's do that. So anonymous inner classes are something you typically would see in like a GUI application. It's basically for a class that would appear only once in an application. And so you'll see something like this, so that the code actually appears where it's used. So for example, I have a button here, and then I'm setting up, this is a swing application. I'm setting up a button, and then I'm going to set up, basically when you click on the button, what to do. And I set that up here, and I'm doing a new action listener there. And notice that I'm basically setting up a class in there where I'm implementing the one method. So it's easier to read here like this, but it's not very elegant. And one of the problems is that it takes quite a bit of code to put in just this one method. And so this is one of the features, per se, that Lambda is addressing. It's trying to improve upon this to make that a little better. Now, this particular case, we're using an action listener. And here I have an action listener, the source code for that pictured here. And you can see it's an interface with a single abstract method. So notice the signature there. We just have the action performed as the only method, and it takes an action event as a parameter. For the purposes of Lambda, this is a common pattern throughout Java, and we're calling this a functional interface. So an interface with one abstract method. And this is kind of what the Lambda expressions are built upon. And you'll see more. We'll see more of this. There's some built-in functional interfaces that you can use with Lambdas, and we'll see a lot of examples of that. But this is a great example of one right here that's already in existing code. So how does the Lambda expression syntax work, and how does it relate back to that? So basically, we address this vertical problem by creating expressions that are built like this. We have, on the left side, we have an argument list, then we have a token, and then we have a body. And you can think of the argument list as, if we go back one, my method there is going to have some sort of argument list. And so typically that's going to match, right, whatever that is. So I've got some sort of functional interface that's going to match that argument list, and then I'm going to have some sort of body. Now that can be an expression. So here, for example, we have two ints. So I'm going to be returning, as this expression will return an int. Then I have just here, I have no, so this one has two arguments. This one has no arguments, but I'm going to return an integer 42. And then finally, this third example here, I have a string argument, and then I'm not returning anything. I'm just going to print out some stuff. So I'll go through some examples here of some functional interfaces that already exist in the language and show how they can be replaced with Lambda expressions. But that's the basics. So argument, arrow token, body. That's basically it. And we either have an expression or we have a block of code on the right side of our arrow token. So that's the basic setup of what the expressions look like. So let's look at some actual examples. So I'm going to jump back to my desktop again. And so I'm going to go to this project. This is the first project you'll find in the OBE. And if I go to my main method, you see here I'm calling 3 different test classes. And so I'm going to go ahead and load those up. I'm going to do the listener, comparator, and then the runnable. So let's look at the listener, and that's just what I talked about. That's where I got the code from, in fact. So this is a Swing app, and I'm setting up a listener for when we click on that button. So you can see here quite a bit of code, a little not quite that elegant. So how would I do that as a Lambda expression? So I would do, let's see here, I'm going to pull this up here. I've got a little cheat sheet I'm going to use for this. All right. So I would do something like this. I'm going to hit the button and add an action listener just like I did before. And then this is where things get different. So once I get in the parentheses here, I think I'm going to go ahead and put the semicolon there. We're going to add a Lambda expression. So I'm going to do an E for events. I'm going to put in my token. And then I think I'm just going to print something out like I did there. So I'm going to put in my brackets like that. And then I'm going to, let's just print out a message. So that's just a little, I just had to S out there and hit tab. That's just a little NetBeans trick I can use to save me from having to type that. So I'm going to click detected by Lambda listener. Okay, so if I save that, so now I've just added another listener. Notice we have our syntax. We have our parameter list. As we saw before, action perform takes 1. So let me highlight that line. Action perform takes 1 parameter, so I have 1 here. And basically, I've got my block. Highlight that line like so. And I'm not returning anything. So let's go ahead and run that. And we're compiling, and then here, probably can hardly see it. See if I can grab it. It's hard to grab. I noticed it's a little hard to grab last night. All right, let's see if I can get the edge here. Well, anyway, I'm just going to go ahead and click the button, and you can see here I get 2 messages in my output down below here every time I click that because I've added 2 action listeners. One the normal way, and then one with the new Lambda expressions. So that's pretty cool. There's another class that has that same pattern as the runnable class. So I'm pulling that test up here, and we're just printing. So what I've got here is just a simple program where I'm setting up runnables, which have just, once again, same pattern, one abstract method run, right, for that interface. And so I'm going to set up a second one here with using a Lambda expression. So I have a runnable R1 up here, so I'm going to do runnable R2. And then once again, I've got an anonymous inner class up here where I've implemented run. So right there, you can see the code there, and then it ends there. And then, so for this, what I'm going to do is I'm not passing anything in there, so that's empty. And then I'm going to do the same thing. I'm going to do a block. And then I'm just going to print a message, say hello world 2, and then with emphasis. And then notice, once again, same syntax, argument list, arrow token. This time we have a block. So I'm going to go ahead and run that one file. Whoops, not that one. We want to run that one. And it should just print the 2 messages. There we go. And then finally, another example of a functional interface would be comparator. And we can see here that we're doing an anonymous inner class right here on this line to do a comparison. So I'm sorting a person list, and I'll talk about that more in the next example. But it's a list of objects. We're going to go through and sort it based on surname, which would be last name, U.S., and that's basically, we have a little vertical problem. Again, I got quite a bit of code here to do this. So let's do it Lambda style. So we're going to do 2. We're going to create a Lambda to do it ascending and descending. So the code for that is basically looks something like this. So it's going to be a comparator of a person. And we're going to call it, got my notes there to help me out, surname ascending. This is our ascending sort. And then I'm going to, once again, I've got this particular, the compare method has 2 arguments. Usually it's just any object. So we're going to pass in person, since that's what we're sorting. So person 1 and person 2. So there's my token, and then I'm going to just call we're going to get the surname, and then we're going to compare that to the second person, like so. So there's my first one. So once again, I've passed in the objects here, and I've specified the types there, but I don't have to do that. Lambda expressions have something called target typing. So when I do the second example, so it can kind of infer what the types are. So that's why you see some of these examples, I don't have anything telling, saying what kind of type it is. So if I do my second one, there we go. So I'm sorting this one descending. And so this one, I'm just going to do P1 and P2. And then Lambda expressions are smart enough to infer that those are persons. And so then we're going to start with P2, get that surname, and we're going to compare that to P1. Like so. And so basically I just have some lists here. Let's try to run that. And it's just going to print us some sorted lists, or should, and it did. Always good in a demo. So here we've got descending. Looks like we're sorting up, see on last name here, and then the first one is ascending. That's from our Lambda expressions. And of course we have our first one up at the top there, like so. So basically, that's what that's what they look like. There's some examples of how you could use it, in some instances that you typically are used today in Java programs. So let me jump back to the presentation. So just to reiterate, once again, it's one of the things it does is improves upon the anonymous interclasses. It uses functional interfaces as the building block for the expression. And a functional interface is an interface with one abstract method. And then there we see some examples. We've got arguments on the left and our arrow token, and then our block on the right, which can either be an expression or a block of code. And then once again, I've got the 3 examples there. So let's look at another example. And this is the Robocall application. This is taken from a presentation done by Stuart Marks at Java 1 2012. And essentially, it's an application that's designed to contact a list of people. And I've expanded it so that it not only phones you, it can also email you and send regular snail mail to you. Whatever list it's sent to, it can do any one of those 3 things. And we're going to contact 3 different groups. So in the U.S., drivers are anybody who's 16 and over, who, of course, they have to pass a driving test, but there's an age requirement there. So we're looking at the groups are defined by age. Draftees are people between the age, male people between the age of 18 and 25. We don't actually have a draft, but you still have to sign up for it. So that's the age range there. And then finally, we have pilots, which have an age range of 23 to 65. So we're going to be working with those 3 groups, and we can contact them in 3 different methods. So we're going to start out with a basic app and try to improve upon it in various ways, and then see how we can improve it with Lambda expressions. Okay, so I think the next one here would go to the demo, and that's it. All right, let's do that. Okay. And so we're going to look at the Robocall example. And let me go ahead and open this up. And so basically, I talked about that a little bit. Let me pull up the first test we have here. And here's the code. And first, we create a person list. So let's talk about the person class. So I'm going to open that up. And see here, it's just a class. We have given name, surname, age, gender, male. So, so it's pretty simple, mostly string. Gender is just an enumeration. I can pull that up real quick. See there, we've got male and female. That's it. That's for the draftees list. And it's set up with a builder using the builder pattern. So if I scroll down to the bottom here, you'll see that I've got a method that gives me an instance of a list. So it's a static method, and that's what we work with throughout the apps that follow. So that's what person is. We're just creating a list of people with first name, last name, their address, phone number, email address, all the things we need for our robocaller to make calls. Okay. And then so the first thing I have here is the RoboContact method, or class. Not method, the class. Contact methods. So what you see here is, for example, so I have methods that work like this. I have a call drivers method, and I go through my list. It gets a list of people. I iterate through the list of people, and then I check for the ones that are 16, and then if they meet the criteria, then they get a call. Then I have another one here for email draftees. So this is an email method. Notice that I do a robocall there. That's a phone. Robo email here. If we scroll down to the bottom of the class, then I just have these simple methods. It just prints out a message now. In theory, it'd be connected to something that would actually make the phone calls or do the emails or whatever. But I also have an email one here, same thing. I iterate through it, I check the criteria, and then I do whatever I need to do. Now, I've only done 3 sample methods here. If you think about it, if I wanted this to really work for all this stuff, I would need a separate method for each group and then a method for each way of communication. So I'd have to have 9 total methods using this approach. So when we work with object-oriented programs, we want to use a principle called DRY, which is don't repeat yourself. And so if I use this method, I'm going to be repeating myself a lot. So let's see how we can improve upon that. So I'm going to close this, and I'm going to go to the second one. So my second example, I'm going to use Contact Methods 2 class. So let's look at that. And you can see here that, so my improvement on this is instead of doing the criteria every time I have a different method, I set up little methods to test each person so that make my code a little bit more maintainable. So that if for some reason my business logic changed, say drivers, 15-year-olds could become drivers, then I don't have to go back and touch each of my methods. So that's an improvement, but I still, if I follow through with what I said before, I still would have 9 methods. I still have a lot of repetitive code, and still kind of violates the DRY principle. Still not a very good example. So let's move on to the third example. So this one, once again, we're getting the list. And this one's calling anonymous robocaller or anonymous class or robocaller. So let's pull that up before I look at in detail at this test class. So this one I have actually improved things. So I'm using an anonymous inner class to call stuff. So if you look at the methods, I've gone from 9 to 3. So I've encapsulated all the test information in this inner class. You see here, when I do my test on my if statement, I'm still iterating through everything, but at least with my test, I'm calling this inner class, and then I'm doing my test here. So I only need the 3 kinds of, so that takes care of the groups that I'm searching for. So that's taken care of. And so I only have phone, email, and mail. So only the 3 contact methods. And then, of course, my end result methods down below, but those don't change. So basically, I've gone down from 9 to 3. That's better. But then if we look at how I did the test method, it's not, we still have, we've kind of just changed our problem. So now, even though that class is a lot cleaner, when I call it, I'm still repeating a lot of stuff. So I'm still doing an inner class. I'm having to set up the criteria every time, like so. And, it's an improvement, and I could, of course, change these to methods, but then it starts getting tricky and stuff. So what does Lambda offer to a situation like this? So let's pull up our Lambda, our final test. And we can see here that I've got to fill some stuff in here. But let's look at we're calling, and this time, RoboContact Lambda. So let's pull that up and see what that looks like. Okay. So I've gone to so I've got the same. So I've gone from 9 to 3 again. And notice here that I'm using something, a predicate. So look at that call list there. So we have a number of built-in functional interfaces, and predicate is one of those. And predicate basically has one method, test, which returns a Boolean. So it works perfectly for this situation. So I'm going to go ahead and let's go ahead and do the Lambda expression and write those so that we can finish off this app. So I'm going to go back here to the main method of our test method, and let's fill those in. And I'm just pulling up my cheat sheet here real quick. Okay. So I'm going to assign these all to variables like so. So I'm going to create a predicate. And if my desktop was working properly, I would actually show you this is all in the API. So if you look at the API doc, you can see the definitions for predicate and all the stuff that I'm working with here. So I'm setting up a predicate. It's a type person. I'm going to do all drivers. And those would be, so that's the 16 age group. So I'm just going to assign that to a Lambda expression like so. And so that's going to be a person dot, I'm going to get the age. And we're going to say greater than or equal to 16. And that's it. Now notice from the earlier examples, everything I did before was a block. That's an expression there. So I'm returning a true false there. So I'm going to do, let me do the other ones here. I guess I should do it based on my comments there. So then we're going to do another predicate. And this one's going to be all draftees. Oops. Got a little carried away there with the D's. Let's see here. So same thing, person, use my token. This one's a little more complicated. We're going to get the age. And we're going to say greater than or equal to 18. And we're going to get the age again. We're going to say less than or equal to 25. And then finally, we're going to get the gender, and that's going to be equal to, all right, so that's that Lambda expression. And then finally, we're going to do pilots. So basically the same thing. And then our age range is oops. There we go, make that look a little better. And then you see there, NetBeans over here was actually showing an error. I cleared those all out. And you can see here that then this becomes a little bit cleaner when we call this, a lot better than the inner classes were. And I'm just going to run this one. And there we go. So what I'm going to do next is I'm going to jump to the collections. If you go to the OBE, there's another quick example on how to use function or the function interface. And all this is under java.util.function. So remember that java.util.function, I would show it, but I'm not sure my system can handle that. So maybe if I have time at the end. So let me go ahead and close these out, and let's go through some of the changes to the collections API. So that's this example up here. We definitely want to get this in. So anyway, so the example I'm skipping, once again, it's in the OBE. You can look that up for yourselves. It's all there. Okay. So, so all the collection APIs have been changed to use Lambda expressions. So I have, once again, a person list. We're using that throughout. I show that there. And then the first thing I want to point out is we have a new for each. So it's very similar to the enhanced for loop, but it takes a Lambda expression as a parameter. So here, what I'm doing is in my person class, I've actually set up a Lambda expression to print out the information in a particular style. And so that's what I'm calling here. So I'm going through the for each like so, and then here's the expression. You know, once again, we've got our arguments, our arrow token, our token operator, and then our arrow token, excuse me, it's not an operator, our arrow token. And then there's our expression. So you may ask, well, why, Mike, do we need a for each loop? So probably this situation, and I can pass a Lambda expression, that's great, but that doesn't really, well, that's not really a good reason. So let's look at another example. I think this helps explain it a little better. So what you can do with the new Collections API in Lambda is chaining and filtering. So you can go through a list. Once again, we're going through a person list. You can go through that and then filter the information so that only the information you want printed is processed. So the concept is basically called laziness, but the idea is you don't do an operation on something until you actually need to do it. So rather than having to iterate through an entire list every time, first we can filter it like so, and then we do the iteration. So I'm going to filter it, and so what I'm doing here is, remember all those Lambda expressions I typed before? So I've gone and I've put this in a class. So I'm going to pull this up. So this is the search criteria class. And remember how I just typed in all this stuff? Well, so I did that again, but this time I put it in a map. Then I put that in a class with a wrapper around it. And so I can just call all drivers, all draftees, all pilots, and then it's going to give me that expression which I can then pass around. So then I have a class get criteria. Notice it's returning a predicate of type person. And so I've encapsulated all that Lambda stuff, and I can just pass it in there, and then it becomes, so I think it looks very clean here when we get in our code. I'm just saying all pilots, do that filter. Then once we've filtered out just the pilots, then we iterate over that list, and then we print that list. So it gives the developers a lot more opportunity to optimize the code, and we can do it. We're a lot more flexible with what we can do with it. Now, one thing I kind of skipped over, but I can't skip over, is notice that call there to stream. So what we're doing, we use what's called streams with the collections now. And essentially what that does is it takes your list, your items in your list, and makes what's called a pipeline. And essentially it has the items in there, but it allows you to do these various operations on your list without affecting your list. So essentially it's like having a copy, doing whatever you need to do, and then when you're done with that particular set of iterations or whatever, then it just throws away that pipeline and there's no change to your list. So a logical question would be, okay, so if I do that, what if I want to save your list? What if I want to save the results? What if I do all this filtering stuff? How do I save that? Well, you can do that with the next example. That's test 3 here. We can get it to open. There we go. And here, once again, but notice this time I'm actually going to return something. So here's my person list over here to the right. Once again, I'm calling stream, which is taking my list and making a pipeline out of it so I can perform these operations. And before I forget, the information you can find about stream, and you definitely want to know, it's javautil.stream or streams. I don't remember off the top of my head. It's one of those. But you basically want to look up that also in your API documentation to get more information about all these methods I'm using. So anyway, I'm calling a stream. Then once again, I'm doing a filter for the pilots. And then finally, I call what's the collect method, which takes a class as an argument, the collectors class. And so that's what stores up all the stuff that's been filtered. And then with collectors, you can then, depending on what kind of data type you're working with or what kind of collection, then you can output the result to that particular kind of list. And as you can see here on the first line, I've done a person list. So I can stream, filter, collect it. So that's how I save results if I want to do that. Now, one final example, I haven't really mentioned stream. All the streams I've used so far, the default there stream, that only works in one thread. That's like a serial stream. It just does, it's one set of items, right? It does it in one thread. So this last example, I'm going to show you like the old style to compare this. But remember, so we want to be lazy. So if the old style of programming this, and this is doing a pilot once again, all the pilots, but I wanted to calculate the average age of our pilots. And to do that old style, what I would have to do is set up a loop, like so. I test for the age, like so. And then I'd have two variables. I'd have a sum to total the ages, and then I'd get a count to find out how many people are in the list. You know, then down here we divide sum by count, and then I can print out the results. And I'm printing out sum and the average both, just because I'm calculating the number. So that's the old style way of doing it. So we're going to have to go through every item in the list every time. But with lambdas, once again, I can filter it, and I also have some new methods that help me with calculations. So this first example, I'm just going to calculate an integer value. Once again, I have my list here. I'm doing a serial stream like so, all pilots. And then if you look at the Streams API, you'll see what the various methods are. I'm using a map here. And so what a map does is it allows you to get part of an object and do something with it. So in this case, I'm getting all the ages, and then in the final statement or final call here when I'm chaining, I'm going to sum it. Once again, this is part of the Streams class. It's built in. You can call sum. I'm returning an integer stream here, and then that's going to total it there. So the other thing I wanted to point out really briefly here, as we're running out of time, is that I don't have to do everything serially. I can do it in parallel. So if this is a really big calculation with a lot of numbers, I can also call a parallel stream. So notice the syntax is exactly the same, except instead of calling stream, I'm calling parallel stream. And I filter things the same way. I'm calling my map once again to get the age, and this time I'm computing the average. Now the average, one thing that you'll notice when you look at the APIs and stuff and play around with stuff, is you want to notice what kind of return values, because the various methods have different kinds of returns. You want to make sure you're returning, you know what you're returning. So for example, in this case, average actually returns an optional double. So, which is essentially, that's a class that is either a double value or empty. But notice that I don't have to iterate through all the people in my list. I only have to go through the pilots because I filtered it here, and then I only have to, work with those particular items instead of everything. So that's the advantage of using Lambda expressions with collections. Okay, so I think that's it. We're almost out of time. I'm going to stop there. Let me jump back here. Once again, here, as I mentioned, this JavaUtil.function and the JavaUtil.stream. Those are the two that you want to look up in your API documentation. So this is a summary. This is what we talked about. Talked about the definitions, some examples. Went through the Robocall app. We had to skip that demo because of technical difficulties, and then we went through the collections. So thanks everybody for listening. I think Peter might have some more polls here. Please finish those up. Once again, there's a lot of Java community stuff. We have forums on oracle.com and java.net. There's local user groups. We'd love for everybody to stay involved with Java. And Java 8 is going to be really cool. All this stuff is really great. And of course, this is based on an actual OBE, or Oracle by Example, which is essentially an online free web tutorial. You can get that at the Oracle Learning Library, oracle.com/OLL. So, Peter, any questions?
No,
or any
thank you.
Comments?
Thank you very much, Mike. At this time, if anyone has any questions, please use the chat window to ask those questions, and we'll take the last couple of minutes to answer your questions.